I'm Robert Smit. I'm going to be talking to you today about BTRee file system, or Btrfs as it's more commonly known. Basically, it was started as an answer to ZFS. Solaris uses ZFS to manage, it's a newer file system in Solaris, and uses multiple disks, etc. And so Btrfs was an answer to that to try to bring those sorts of functionality to Linux. It's highly integrated into the kernel. It can store up to 16 exabyte, which is like more volume. I think it's like beyond terabyte, you've got petabyte, and then you've got exabyte. So it can store up to 16 exabyte, and the files can be just as large. Speeds are comparable to ext4, the newer ext version, but it's still being optimized, so it's not too fast yet. It should be faster in the end. There's a tool that'll convert from ext4 or ext3 to Btrfs, and it converts it in such a way so as it's done as a snapshot, so you can roll it back at any time. So why did they not just take ZFS? Well, part of the reason is that, first of all, you can get ZFS as a fuse, which is like a user-based file system, so you can mount a ZFS file systems, but on a per-user basis. But the main reason they didn't really take it on straight out was that the licensing issues. Solaris uses different licensing, Sun uses different licensing, and it doesn't fit neatly. It's not designed from the ground up to be fitting into the Linux kernel. And also, Btrfs leverages the code that's already there. So, for instance, Btrfs supports RAID, and it's actually reusing some of the RAID code that's already in Linux. Oops, wrong direction. So, just a bit of an overview. Like ZFS, it uses a pool of drives. It doesn't care how many drives. You just add a new drive to the pool, it'll start using it. The file is spread across the drives, shared, load shared, and all that sort of thing. You can divide it into subvolumes, which you can mount individually. It uses a copy on write philosophy, which I'll get into later. And it uses a BTRee directory structure, which is, as I understand it, similar to what Riser FS, and Riser was quite a popular file system in its day. Small files are actually stored within the directory structure. So if you've got most file systems, when they put a file on the disk can only be divided into so many blocks, and each block is such a size. So if you have a 1 byte file, it's still got to take up a whole block. That's, of course, wasteful if you've got many small files. This gets around that by actually storing small files within the actual directory, within the actual metadata, that the directory structure itself. Snapshots, which is just a way of saying I want a copy of what this file system looks like today, is just another way of doing subvolume. It's similar to subvolume. It just basically links the same data to a different structure, so as it's got a copy of the current state. You can then make more further changes, and that current state is still available. So it stores all its data. It checksums everything. Some file systems checksum the directory structure. This checksums both the metadata, the directory structure, as well as the data itself. Snapshots and subvolumes, like I said. It's got built-in RAID. RAID 5 and 6 are coming, but they're not there yet. It'll support transparent compression, so it makes no difference whether it's built into the file system. This has a similar sort of, you can do the current thing with LVM at the moment, where you have your logical volume and then you put your RAID on top of that, or vice versa. So all this is combining all that into one, to be part of the file system. So it's all part in one big package. It understands solid-state disks and can treat them differently. Solid-state disks being new technology, it doesn't work the same as conventional disks. There are some caveats that their file system's got to do differently. These days, it's usually masked by the fact that the hardware on the disk takes care of that and makes it more transparent to the operating system, but there are certain things that the file system can do to optimize for solid state disks. It's also going to do online defrag and balance, which is basically spreading the data across the disks so as to use the disks more evenly. You can add disks to the pool of disks being used and take them away on the fly. Although when I tried it this afternoon, it didn't work. Apparently there's a bug. Like I said, it's a new file system. And you've got the in-place conversion, like I was saying, from ext with snapshot and rollback. So what is copy and write? The whole point of this file, or one of the key points of this file system, is that it uses copy on write. That means that if you copy a file, it doesn't actually create another copy of it. What's that noise? Right, okay. So when you copy a file, it doesn't actually create another copy. It just creates another pointer to the same file in a similar sort of way that you have soft links and hard links in current file systems. What happens then is if you change one of those copies, at that time, it'll actually copy the data out. This has a big advantage. It means that a lot of the times, a lot of the files on your hard disk are exactly the same. You go to, for instance, your user's home directories. A lot of the config files in your home directory is exactly the same as every other user. So it gets rid of a lot of that duplication of data. It works at the block level too. So there's a potential there that if you got a file that's yay big and you change the first half and the second half is the same, your copy will only change the first half, so you'll have a duplication of the first half, and the second half is being exactly the same. It's going to be the same data on the disk, not just a copy of it. And they have planned for deduplication, which basically means that because it's checksumming all the data, it knows when the data is different. And if you've got two files that are exactly the same, even if they're named differently, there's a potential there to actually say, well, these two files are the same. I'm just going to merge them up on the disk and store it once rather than store it multiple times. So you can imagine a user system. Someone's got one copy of a video. Another person on the same system has another copy of the video. Oh, those two are the same. Suddenly less space used. Yep.
Would you know if that thing would work also across different disks?
If the disks are part of the same file system, yes, it should. So to make a file system, so I'm just going to do a little demo here. So the shortcut key didn't work when I tried this before, so I'll just have to go through the menu a couple of times. So if we do make FS, I've got a couple of, just to show you what's here, first of all. Get root access. Did I get the wrong? Oh. So because I don't have more than one hard disk on my computer here, and I didn't want to repartition or anything, I've got two raw files here. So they're going to be my hard disk for this demonstration. And basically all I'm going to do is set them up with a loop device. So that means that these two loop devices are going to be my hard disks, the dev loop 1 and dev loop 2. It's the same sort of thing as what you do when you're mounting ISO images, for those who are familiar with it. So I then can just do make fs, BTRFS. Some of the commands refer to the logical volume name, which is the file system label. So I'd recommend you label if you're trying it out, because otherwise you may have difficulty referring to the drive you're trying to refer to. All right, so that's created that. And then we can mount that. Sorry? Okay, yep, like that. All right, so we can just mount dev loop 1 as being on mount. And of course we can change into mount. And we've got our file system, create a test file, etc. And then we can add another device to it. So we can just do BTRFS, devices, add dev loop 2. Oh, I forgot to tell it what it add it to. So add it to that same mount point. And you can see that nothing's really changed there. But if I was to do it goes and checks all the hard disk volumes, you can see that it's actually got 2 drives now attached to that same volume. You can mount it by either drive. So if you were to unmount it and mount it again, you can mount it by loop 2 or loop 1. It doesn't make a difference. It'll realize it's part of the same file system and map it accordingly. So we could also go into BTRFS, file system, so you can balance the data across. A little quicker last time. If we share the same file system again, you'll see that the data is now more evenly across the 2 drives. You can also remove the drive with this. Oops, go back. With this BTRFS device delete, but like I said, there's a bug at the moment. It doesn't do that very accurately. It complains. You can also create it as a RAID, and you'll notice that we actually specify RAID twice, because you can actually RAID the metadata and the actual data being stored as 2 separate things. So you might decide, well, I don't want to RAID my whole system because I need the space, but my metadata being more important, I want to duplicate that across both drives. And like I was saying before, you can mount it by either point. It doesn't really care. You can also mount it with a degraded argument in your mount options that basically tells it mount it even if one disk is in error. So, yep. It's coming, but it's not there yet. They've also got some other neat little things that they can do. You can actually mark one of the disks as being read-only. So I found this as a little blog by someone who's basically using the BTRFS tune to say disk 1 is read-only, mount that, and then add another device to it that is read-write. So now you've got one disk that's storing, say, your base file system with everything as you originally installed, and another disk that's storing all changes from that point. So you can very easily come back to the original file system. Maybe you have one disk that you want for read-write, read-only for a particular reason. Maybe it's a CD. You can create subvolumes, which are quite easy to do. So if I was to do BTRFS, if I can spell it correctly. Now if we do ls, you'll see that there's a directory there called test sub. If I was to mount that file system with the option subvolume equals test sub, then it would actually mount the contents of that directory as being the root of that file system mount. Snapshots are pretty much the same sort of deal. There's not actually that much different between a snapshot and a subvolume. It's just the only difference is that it's been filled with pointers pointing to all the same data as in the original disk. And of course, if you take a snapshot, it doesn't actually copy any data. It's again the copy on write philosophy. So the data is identical. It's the same piece of data. It's just a different set of pointers to that same data. It only starts changing when you start changing those files. You change one of those files, suddenly you've got a copy of that file. You change another of those files, suddenly you've got a copy of that file. But that means that it doesn't cost you any room on your hard disk to take snapshots. The snapshot that you're using is only recording the changes from that point. Either. You basically take a snapshot of if you take a snapshot of the, let's see if I got here, whoops. So if I did Btrfs, subvolume, snap, there's one that's gone. So you can say I'm going to take it from this point, or you could say I'm going to take it from some directory. I'm pretty sure that's how it works. I didn't like there. I don't know what I've done wrong there. I'll come back to it. I've got it back to the front. That's what I've done wrong. So if you do it now, you'll see you've got the snapshot there, and you can do BTRFS. Yeah, sub. You can see that the snapshot is the same as the subvolume. There's no real difference between it besides what data it's pre-configured to point to. You can also, like I was saying, mount a subvolume, so as that subvolume is the root of your mount point. And you can set the default subvolume. So say, for instance, your system was configured to mount the home directory, which is a Btrfs file system, and you took a snapshot, and the next day you wanted to roll back to that snapshot, you could just change the default subvolume so as to be that snapshot, and next time it boots, next time it mounts, it'll mount that snapshot by default without having to specify that I want to mount this particular file system or change what your mounting configurations were. There's some neat little features that they're planning to bring along. Fedora apparently is planning to integrate it into Yum. So the idea would be that if you're going to do an upgrade of your file system, an upgrade of your operating system, it would take a snapshot before it does the upgrade, does the install, and then at any point, if something goes wrong, you can roll back to the previous snapshot. So upgrades become rollbackable, for want of a better word. And Nautilus, apparently, the file manager for GNOME, is planning to, there was talk about making like a timeline. What does Mac call it? There's some Mac, sorry? No, yeah, there's some Mac tool. There's some Mac tool that allows you to basically roll back through.
roll?
No, I think it's called Time Machine or something like that.
Oh no, it'd be called I'm Machine.
Yeah, Mac has some backup tool that goes through fancy graphics and allows you to roll back to different older versions of the file. So apparently Nautilus is planning to do something of the same sort of thing. You can find further information on the Btrfs wiki kernel. It's integrated in the kernel already, but it is still marked as being experimental, so don't trust your file system to it, unless you're just trying it out. And that's pretty much it. Any questions? Yeah?
With regards to copy on write and snapshots, well, I'm thinking that if your older snapshot, say your file system is damaged,
Yeah.
and you wanna, well, wouldn't that damage all your snapshots that rely?
Potentially, yeah.
So,
But I mean, if your file system's damaged, then
no, but
any file could be.
When we think that a snapshot is can be used as a sort of a backup, and then if you like combine it with multiple disks, then maybe you'd get some sort of backup.
Well,
but that isn't really the case, is it?
No, because I mean, it's the same. If you take a backup of your files and you store it on the same hard disk, that hard disk dies, you lose your backup too. That goes for any sort of backup system. It's ideal for what you would probably end up doing for want of backup process. Take a snapshot, then back up that snapshot to somewhere else at some other time.
Can you tell Btrfs to actually serialize the snapshot to do the copy?
What, to actually duplicate?
Yeah.
I don't think so. The idea is that the point, even if you did a copy of the data, it'd still be on the same hard disk. So you're still not backing up. A backup should be off onto a different hard disk, ideally off onto a different site.
You should keep using whatever mechanism you're currently using for backups.
It just makes it a little neater because you can say, if you're doing a backup now, right, your backup could be working its way down the directory structure. You go and change this file, that file's already been backed up. It's still working down. You know, in a working environment, if you're doing a backup, there's the potential there that during your backup, files are changing. With snapshots, you overcome that potential problem because you take a snapshot is instant. Then you can copy those files off somewhere else, and you know that there's no further changes happening to that snapshot. Yeah.
And you would copy, you keep a backup copy on the second hard drive. This would, I mean, that would work.
Well, if you had them as two separate file systems, it works just the same. You don't have to make those two hard disks part of the same file system. It's up to you. So the idea of being able to pull the disks is that you're able to say, for instance, you've got a 500 gig hard disk here, a 500 gig hard disk here, but you need a mount point that's a terabyte. You put them both on the same file system, the same Btrfs file system, and you've now got a file system that's got 1 terabyte of data storage. So it's the idea of pulling them together to be used together. You could also do it as a RAID. So you can say, okay, well, I've got 2 hard disks here. I want to mirror it rather than go through all the trouble of doing logical volume management, RAID, and all that other thing, which are 2 separate things. So you have to set up one on top of the other and all that, etc. You can do it within Btrfs as being, okay, these are my 2 hard disks. I want them rated, and it's part of the same pool. You can then come along later and say, okay, well, this hard disk is not starting to go a little flaky. I'll add another hard disk to the pool, fix that up, now take that flaky hard disk out, and it'll copy that data across dynamically. So if you've got, say, a pool of 2 hard disks, and one of them is starting a little go, or maybe you only got 2 positioned for 2 hard disks, but one of them is a little small, and you want to put a bigger hard disk on, put a 3rd hard disk in, add it to the pool, spread the data across there, and you say, delete the small hard disk or the faulty hard disk from my pool of hard disks, and it'll go and say, well, move all that data onto the other disks in the pool, Now I can remove that disk safely. These are the sort of features that FS has been offering too. It allows you it allows you more flexibility in managing your pool of hard disks. It's not so much designed for an individual machine, although it can be used for an individual machine too. And one of the key developers of ext4 has said himself that ext4 is only a stopgap measure until Btrfs comes into reality. So even the developers of ext4, which is the new version of ext, are saying that this is only a stopgap till Btrfs comes along. But one of the key goals you're gaining is that you're going to have the ability to have on servers multiple hard disks and be able to add hard disks, remove hard disks, extend the file system across more hard disks. So it gives you more flexibility for managing your disks and using it as a pool rather than like if you wanted to add more space to your computer at home, you're going to have to add another hard disk. Then you're going to decide where to mount it. You add another hard disk onto your computer. You tell it this is part of this. Add it to this Btrfs file system. There you go. You've got an extra terabyte. Doesn't need to know it. You don't have to muck around remounting, changing mount points, copying the data across. It saves you a lot of hassle. Any other questions?
Which of the Btrfs features will now be in, or which of the ZFS features will now be in Btrfs?
Well, I don't know of any that aren't, but the goal of, well, the main motive for bringing Btrfs into the world was in answer to ZFS. So my guess is that anything that Sun come up with for ZFS, someone will come up with for Btrfs because that's their main competitor. And just like GNOME and KDE, one developed something, the other one said, oh, that's a good idea. I'm going to take that and do it too. So I can't imagine there's not going to be too much that won't, at least not too much useful stuff that won't be copied across to the other project, to the Btrfs project.
Can you match snapshots?
Sorry?
Can you match snapshots with the original basement? So can you make a snapshot, the main, no longer snapshot, but the original volume?
So so to
Then, like in Rails 6, there's basically sort of introducing meshes. Then you can make a VM snapshot. You can make what do you call it, original volume.
yeah.
So for example, when you want to basically make the snapshot, like the main file system, you don't need anything that was in the original volume.
Yeah, I see no reason why you couldn't. It's just basically
No, originally you couldn't. In Rails 5 you couldn't.
okay. So you're talking about taking a snapshot
So yeah,
of the original file system.
made a snapshot, and basically you work with the snapshot. You make some changes,
Yeah.
and you no longer work with the original sort of volume.
Okay.
Keep on going with the snapshot. So originally it's like with MDM. What we have now it's like it's copy on write. It takes more and more and more space.
Yeah.
And maybe you will end up using basically twice the space.
If you continue, yeah, I suppose, yeah, yeah. So you want to be able to delete the original snapshot.
And no, the original sort of volume, and make the snapshot out of snapshot.
As I understand it, and I'm no expert on this, but as I understand it, there's not much. Everything is basically a snapshot. So even the original volume is just a snapshot. I see no reason why you couldn't then just delete it and just say, well, change my default snapshot to be this new snapshot, and I see no reason why you couldn't delete the original snapshot. It's all just pointers pointing to the same data.
But the developers of Btrfs have been breaking standards of Linux kernel development quite a long time. So basically they, like, Linux didn't allow for developers of Ryza 4,
Yeah.
to allow us to do for the Btrfs developers. Getting to the level of log device, right? Which, for example, originally all the file system developers were constrained to the BFS layer.
Yeah.
And Btrfs developers going to the
I would imagine that's, I'm not so sure of the details, but I would imagine they've got to cross boundaries a little bit because they're basically logical volumes are going, the functionality of logical volumes is going to be integrated into it. The functionality of RAID is going to be integrated into it. So I know they're bound to be breaking down barriers between them. I know that they are working to integrate heavily into what is currently there. For instance, apparently they restructured some of the RAID code within the kernel and restructured some of the Btrfs code in the kernel. So as the Btrfs is using the same RAID code as what the original kernel is. So the idea is to try to integrate them all into a cohesive thing rather than, you don't want to end up in a situation where if you're doing RAID without Btrfs, you're using this code, and if you're doing RAID with Btrfs, you're using that code, because that always ends up in trouble. Then you've got two copies of the code, and potentially, one falls out of sync to the other, one does something this way, another does something that way. It just increases the amount of trouble with bugs and all the rest of that sort of thing. So I know that they are working to try to bring it into a cohesive group and reuse a lot of the data, a lot of the code, rather than reinvent the wheel.
Do you know any examples of like VM
Of logical volumes? No. Yep.
Does OpenSolaris use
ZFS,
ZFS?
I believe it's available in Open Solaris. I remember when I was working on Solaris, you couldn't boot to there were limitations on what type of ZFS file system you could boot to. So if you wanted to boot, you had to still use UFS, the older UFS, and then, have your data directories and that sort of thing on ZFS and pools and all that sort of thing. So there's still limitations on what you could boot to. And those limitations are currently in Btrfs as well, because Grub doesn't understand Btrfs. So if you want to use Btrfs on your Linux machine, you have to have a boot petition that doesn't use Btrfs, and then have further petitions that have. I think they're working on it. I don't know how far they got, but okay.
Bring him up. Bring him up.
Okay, that's good. That's good news. Yeah. Yeah.
A couple of days ago, I talked to one of the Red Hat people, and they said the reason why they didn't do it is because when they started testing it heavily, the data centers, some of their clients,
All right.
there were basically losses of data. Serious that couldn't be basically people they couldn't get the data back.
Yeah.
And
Like I said, it's still very much in development. I know one of the blogs that I read was telling me the command was this, and the command had actually been changed. So that's where you add device. I think it was, when you balance the device. It used to be Btrfs device balance, blah. Now it's Btrfs file system balance. So that they're changing the command structure to bring some sort of cohesiveness to it.
do you know any cases like of data, of people lost their data among your friends or maybe you yourself?
No. I've actually got my home directory on Btrfs on this machine. I haven't lost data, although I've seen some odd things happen. I would say there's two petitions there as part of the Btrfs file system for my home directory, and I couldn't remove one of those petitions from the file system, and I couldn't expand it out to fill up the whole file system. So there are still, it is flaky at the moment, but it is improving.
What operating system do you use?
So operating system, this is Kubuntu.
That's the recent release,
Yeah, 10.10. Anybody else?
So did you install Btrfs as your primary file system or not? On Ubuntu 10?
Well, when I put this on, from what I had read, you couldn't have it as your boot device. I installed it as Btrfs and then copied my files back onto it. So it was a fresh install and it worked for me. But I only put the home directory under Btrfs. I didn't put the main partition, the root partition or the boot partition or anything like that.
Well, by the way, like sort of another news, the last couple of days there have been one Indian company has actually created a kernel module for the ZFS. So
Yeah, I thought I read something about that.
so it's actually being sort of released. Well, basically it's heavy tested now.
Yeah.
So people can use it. You can download a kernel for the ZFS and use it as a native Linux sort of file system. I don't know what.
Does that mean that that's because they had to fit it in with the Linux kernel? Does that mean that it's different code to what the Sun ZFS is?
I don't know.
Because if it is, then that you've got that same duplication problem with potential bugs in one and not in the other.
ZFS or the Linux kernel, specifically to get around the licensing problem.
So they
Yeah,
get
but
around.
in any country with software patents, the patent is not the code, the patent is on.
The problem isn't patents. The reason that ZFS couldn't be included in the kernel is because it's released under the CBDL, which is not compatible with the GPL. So because they released it under the Sun open source license rather than the GPL license, those two licenses aren't compatible, so they can't put the ZFS code in the Linux kernel. So that's why they had to do a complete re-implementation of ZFS. However, the people doing the complete re-implementation of ZFS aren't, like, they haven't been doing it in the open. They've kind of just done this code drop the last couple of days. So the likelihood of this getting into the kernel isn't that high. It may end up there. I mean, things like Zen ended up in the kernel, and I would have said that Zen would never end up in the kernel. But there's still a long way off before it's a default part of your Linux kernel.
And even if it does, it means that the code is going to be different between Solaris and Linux, which means there's a potential that Solaris does something slightly different to Linux and the ZFS file system suffers.
Not only that, but if Btrfs is on its way, you're pretty much.
Oh yeah, from what I've heard, I've used a little bit of ZFS, but it was on production system, so I couldn't really play on it. But from what I've heard, Btrfs is going to be more simple to use, more user-friendly, more flexible.
The main reason you want ZFS in the Linux kernel is so you can mount your old Solaris stuff. That,
Compatibility.
Because Oracle's done something that you don't like.
Out of interest, why is balancing important?
Well, in RAID, it would probably happen automatically because the fact that that's the purpose of RAID, that the data gets striped across or mirrored across. But for other file systems, it might just be that you want to share the load of the hard disks. Obviously, the hard disk that is containing the most data is going to have the most traffic coming to and from it. Whereas if it's balanced, well, then suddenly the load is balanced across your hard disks. Yeah, that's true too.
Performance reasons as well, right?
I wouldn't think it's mainly performance.
You're going to read twice as fast, in theory.
Yeah.
In practice on desktop systems, no guarantee. But on a server system, definitely you're going to get twice the performance if you have.
Also, just wear and tear your hard disks. I mean, obviously, if one hard disk is storing 90% of your data, it's going to be the one that's being used 90% of the time. It's going to fail before the other one.
By the way, not just like about Btrfs or like BTRee, is there in Linux some code, the Linux kernel that basically balances like in terms of software between the hard drives that are of different sort of speed.
Right.
That would take it into account the speed of the drives. Is there any code like that does it? Is there any way?
I know it does I know there is code in the Btrfs file system to take it into account solid-state disks, and one of the primary reasons for that is that they perform differently. Seek times are obviously enormously better, but you want to try to avoid writing to repetitively to solid-state disks and things like that, because solid-state disks are only good for so many writes before that section fail, and obviously you don't want it always writing in the same point, because then that section of the solid-state disk will fail. So you need to load share on load sharing is a lot more important on solid-state disk. I know they do that sort of thing in Btrfs, so I'd imagine that's a similar sort of mentality. You're trying to share the load, share the optimize for individual drives. This drive is faster than that drive, so therefore I should, store the data this way. I know there is talk about that sort of thing, but what exactly they're doing, I don't know.
But is it actually like within one drive? Say, for example, you write in this way, like for this particular drive. Isn't that's a load balancing with the different drives?
Right. So you're talking about load balancing within the drive?
No, I'm talking about between the drives, yes. Not within the drive, but between the drives.
I know.
Taking into account basically different properties of different drives.
Yes. Yes. I know that I've read quite a bit that has mentioned that they're optimizing for individual characteristics of the drives, not just solid state or not solid state, but also for other stuff.
So I know BTRfs specifically has the ability to have things like cache drives and stuff like that. So for example, on a server system, you might have one of those Raptor hard drives which run at like 10,000 RPMs. They have like a much better sync time than other hard drives. And what BTRfs will do, you'll look at the access profile of the files and move the files which are like small and need lots of random access onto the Raptor and move the big files that you access sequentially on other things. And since ZFS does this, it's likely that BTRfs...
That certainly fits with what I've read, that they're optimizing for different drives.
For that now, but SSDs are horrible to cache because like they have bad write performance and stuff like that.
Most of that write performance problems is because of the way they store the data. They can't, with solid state disks, you're only good for so many writes. So what they do is they don't erase data from a solid state disk until they absolutely have to, because erasing data unnecessarily is basically wearing out your drive faster than necessary. So they leave the erase to the last minute. So that means potentially when your disk is almost full or getting close to full and you go to write a file to a solid state disk, suddenly it has to go and erase, make room for it by erasing blocks of data. And it can only erase the data in blocks. So I can't just sort of say, well, I'm going to store this file here. If that file is, say, for instance, in the middle of 2 blocks, so say it's on the border of 2 blocks, it has to read all the data out of that block, erase it, rewrite it back with the changes, then read all the data out of this block, erase it, rewrite it back with the changes. So you can imagine that's quite slow. There are new codes within the SATA protocol for optimizing that, in that there is now provision in the messaging to the hard disk that sort of says, well, this block of data is actually not storing data anymore. So you can erase it when you want to, rather than previously with old file systems that don't know anything about solid-state disks. They wouldn't do that. They'd either erase bits and a bit of the block, or just leave the data, or whatever. They've now got these additional trim commands, I think they call them, for solid-state disks, and that's one of the things that Btrfs has taken advantage of to more optimize solid-state disks. So that's about, sorry, yep.
How do you find the metadata overhead? Does it take up much of your file system when you balance out before it seems to?
I think a lot of this stuff, like I said, a lot of these is still up in the air. And from what I've seen of the commands, they don't necessarily report the usage accurately. Like if you remember when I did that Where was it now? Like when I did this file system show, you can see that according to it, it's using 207 megabytes, but there's only one file that's got like a K on there. Add to that when you got the duplication and the copy on write type file system, how much space is being used on that file system becomes a little bit difficult to quantify, because you might have 100 megs worth of data on that, but some of that is duplicated and therefore you're only using this much data. So things like tools like disk usage and that sort of thing are going to have to be updated to understand this sort of stuff. And then which way do you want it to report when you're doing it, when you're doing a display and you want to show that stuff? Do you want to see how much data is there, or do you want to see how much data is actually used? Because the two are not necessarily the same anymore. So a lot of these sorts of things are still up in the air, and the command syntax is still changing. I wouldn't say it's that straightforward. Yeah. Yeah. Well, that would change the whole thing again, because then, you know, when you're doing a display of how much data you got on your hard disk, do you want to see how much data you have, or do you want to see, you know, how much is actually used? Yeah, yeah. But this is the sort of thing that's still, you know, the commands are still being structured. You know, the options may not be there yet, but they'll probably be there in the future. It's really still up in the air.
Well, I think this is an interesting conversation that we can continue, but we can continue it at the pub.
One last point. I'm currently looking for work, if anybody knows anybody. So come talk to me.